Example 8, finding an equivalent fraction for a repeating decimal. We want to find an equivalent fraction for the repeating decimal 0.3. Now first, we noticed the repeating decimal 0.3 is equal to 0.333 and so on. So we can rewrite the repeating decimal as a sum of terms. So let's take a look at this. We have 0.3 repeating. We can take 0.3, which is 0.3, plus the 0.303 or 300ths, plus 0.003, which is 3,000ths, and so on. Because this 3.0.3 and this is 0.03.003. Now, we want to look for a pattern. So we rewrite the sum, noticing that we see the first term multiplied to 0.1 in the second term, and the second term multiplied to 0.1 in the third term. So what we're doing is we're finding the common ratio r. So we take the second term, 0.03, and divide it by the first term, which is 0.3, which gives us 0.1. If we do the same thing, if we take 0.003 and divide that by 0.03, then it's also going to give us 0.1. So now we know that the first term is 0.3, and we know that the common ratio is 0.1. Noticing that pattern, we can multiply each consecutive term by the common ratio of 0.1, starting with the first term of 0.3. So we can substitute these values into our formula for an infinite geometric sum. So again, S is going to equal the first term divided by 1 minus the common ratio, the first term being 0.3, divided by 1 minus the common ratio of 0.1. So we get 0.3 in the numerator. 1 minus 0.1 is 0.9 in the denominator. So if we want to then get rid of the decimals, we want to move this over 1 decimal place and 1 decimal place to the right, which means we're going to multiply the numerator and denominator by the power of 10. So 0.3 times 10 gives us the value of 3. 0.9 times 10 gives us a value of 9. So 3/9 is equal to 1/3. So basically we've proved that the fraction, or the equivalent fraction, for the repeating decimal of 0.3 with a line over it is 1/3.